To evaluate this limit, we want to make sure the left-hand limit equals to the right-hand limit. If they are equal, then we can say this actual limit exists. So let's start by defining a function by using this function notation equals to this 1 over x, because it will be easier for us to write a limit later on. Next, since we want to test the both one set limits, let's start with the one set limit from the left hand side, f of x. So since x approached to 0, we want to pick a number first that is near to 0. So here's a 0, and pick a number. It might be negative 0.1. And we also want to pick multiple values just to easier for us to figure out the function. So let's use the table here. Here's the function. And the first value will be negative 0.1. Next will be negative 0.01. It's getting smaller and smaller. And then negative 0.001. You can continue if you want. The f of x, you can figure that out by replacing the x with this corresponding value and plug those values back into this 1 over x. Just use the calculator to figure out that. So in this case, it will be negative 10, negative 100, and negative 1000. Here's the problem. If you see this pattern, even though this y value goes larger and larger, but it doesn't seem to lie towards a specific value. For example, like 1.0021. The next value will be 1.0011 or 1.0001. So you can see this pattern, and it's a similar number, and it goes smaller and smaller, and you can see the next value just towards the number 1, right? But for these three numbers or the patterns, it doesn't seem like towards the specific number, so it seems like it goes infinity. So here's the infinity sign. Then we say this limit does not exist. If you want, you can put the infinity, right? It goes towards the infinity, but it's just the same thing to describe the same phenomenon. Here's the left-hand limit. Let's see the right-hand limit. For the right-hand limit, as x approaches to 0, we put this plot sign here, this function. Again, use this table here. And since it starts from the right-hand side, we want to pick the number from the right-hand side. So it might be 0.1, 0.01, 0.001. If you want, you can continue. Same thing, you put the x values back into the functions, and then you can figure out the value. So it would be 10 and 100 and 1000. Again, it also seems like goes larger and larger and goes infinity. So in this case, it does not exist. So let me give you a visual here, what that might looks like. Here's the graph of the function 1 over x. 1 over x, okay. And it roughly looks like that. Okay. This arrow means it goes infinitely. It goes on and on, but I cannot draw because is limited. I mean, this is space. We don't have a lot of space. But you know what? Since the 0 is right here, here's the x value. And if we start from the right hand side, or the left hand side, even though the value goes to towards this 0, but you might see the y value goes down, right? And it never stop. For the limit for the right hand side, even though it goes towards this 0, but the graph shows us it goes up and never stop. So it goes infinity. Then we can say the limit does not exist. Right? Let's conclude this. Since limit of this function as x approaches to 0 for the left hand side equals to the limit as x approaches to 0 from the right hand side equals, there does not exist, then we might say the actual limit of this function does not exist. And here's the final answer.